Web3 Bridge Cohort 9, sponsored by Base.
I'll give you a summary of week 13 here at Web3 Bridge. Week 13, we were introduced to smart contract security, and our mentor went further to show us different platforms to improve our knowledge of smart contract security. We looked at SoloDit, where various reports of different audits are compiled.
We introduced to SoloDit, we introduced to internal, to introduce to know that these are all platforms to actually advance your smart contract security knowledge. We were also introduced to some platforms like Code Arena, Sequoium, and all these security, advanced contract security firms that actually aids smart contract developers to improve and their knowledge in smart contract security.
Gas optimization is basically a way to reduce the amount of gas we use. Reduce the amount of gas we can use while editing our smart contract function. So one of them is by reducing access to storage. E.g., if you can actually store a state variable in your function by catching it to like a memory instead of you accessing the storage or reading from the storage back and forth over and over, you can actually catch it in memory, then have reduction as a memory variable. You can also pack variables in slots. E.g., instead of you using a unit 1 to a 256, can actually reduce it to unit 1 to 8 or unit 8 as well. If you see that this particular value won't necessarily pass a unit 1 to 8, and these are the downsides because the EVM has to unpack, and that also requires gas. So you shouldn't pack variables loosely. So most of the time, for you to want to pack variables, you should pack variables if these variables are to be accessed together. Most of the time, it's always safer to pack variables in a slot.
We looked at the fact that in terms of errors, custom errors cost cheaper gas than using a normal required statement with strings. So if you write your custom error, it costs you cheaper gas than using a required statement. And then we looked at the fact that when you have to call an external calls should be cached. That is when you need to call them multiple times. It's better you just cache them once, and then every time you reference it back, you are not going to pay just for the first time that it was cached.
We also looked at different vulnerabilities smart contracts can have. Then we have CTLs. These CTLs actually expose me to different vulnerabilities, e.g., the reentrancy. Reentrancy means saying that a particular contract calls into another contract and executes a function. While the function is being executed, another function is executed as well in the contract. The reentrancy can be overcome by you making a state change before making an external call. E.g., you can actually update your state change. If you want to make a transfer, please update your state change before you do a transfer or something. And it is also advised not to store sensitive data on the blockchain. E.g., you may say that there may be something you see like a private variable or private visibility. This does not mean that the storage cannot be accessed, or the value in that slot can actually be accessed by just querying the data on the slot by using assembly or waitas.js or web3.js. We also had a vulnerability where we're asked to check for when a smart contract has 0 code. I mean, that was a bit difficult. I was not I didn't have that knowledge prior. So when we solved that system, I realized that at the construction time, the contract has 0 code.
And I'm actually so grateful to our mentor, Miss Mora. She has been so good in our development journey, smart contract development journey. It's been so great. Thank you to Web3 Bridge. Thank you. Bye.
Web3 Bridge Cohort 9, sponsored by Base.